Okay. So I'd like to welcome everyone to our inaugural Sustain presentation. This presentation will be monthly. It'll be on the third Thursday of the month at this time. We'll send out the information as we did for this one. If you've already signed up, you will definitely be on that mailing list. And what we're going to have is, focusing on what Sustain is the workforce. And for today's presentations, we're going to kick it off with the presentation from Workforce Needs for NuScale Power. And Steve Mirsky, who's part of NuScale and part of our Sustain project, is going to lead it off. And then after that, I'm going to give an overview of Sustain and show where we are, and then talk about where we're going into the future. But the real mission of Sustain is to try to develop a workforce for the nuclear power industry. So I know that there's other entities from nuclear power groups that are online. And what our project is really to do a gap analysis and understand where we are today, where do we need to be in the future, and how do we get to that point in terms of workers. So to get things rolling, I'll ask Steve to give his presentation. And Steve will nominally go 30 minutes. I'm going to let him go over because I think that if anyone's coming here, I think they're probably more interested in what NuScale it has to say than Sustain. But I will certainly go over and make sure we cover Sustain. And it's really just an overview of where we are right now. So Steve, the floor is yours.
Thank you, Ken. First, I want to make sure, can everyone hear me well?
Yes.
Okay, good. Okay, thank you for inviting me to make this presentation. My name is Stephen Mirsky. I'm a senior technical advisor with NuScale Power, and I have 47 years of experience in the nuclear industry. And with that, I'm going to start with my PowerPoint presentation. If you have any questions, I guess you could either put them in the chat, raise your hand, or I'll wait at the end. It's not that many slides, but still I want to make sure I get through it all. So hopefully everyone sees the slides now. I'm going to look for just heads to nod up and down. You don't have, very good. Okay, so I gather this data and information to provide the NuScale Power perspective for our SMR design for workforce evaluation. That is the workforce we need, the workforce we have, the nature, composition of the workforce, and how we are going about trying to achieve goals on our workforce. Because NuScale is partially funded by support from the Department of Energy, we always provide this acknowledgement and disclaimer slide, which just states basically what I'm presenting you is the opinion of NuScale. It's NuScale, not the United States government or the Department of Energy. So I've broken up for NuScale SMR business 4 different, I call them functional categories. The corporate office, the manufacturing of the module. And for those of you who hopefully know NuScale, our design is a small modular reactor that uses a very innovative, passive, simple, safe, pressurized water reactor design, site construction, and the operation. And I've listed here some subcategories. These are not all, but they are taken literally from organization charts or other means of dividing up what the functional categories for these 4 are. I want to point out the module factory is to produce only the module. The balance of the plant is to be constructed on site. So at NuScale, we're looking at 4 different types of educational requirements. We look at that in terms of these 4 functions that I mentioned before. There is 4-year college degree. Is not just 4-year college degree. It could include an advanced degree or a PhD. We're not differentiating that. These are what I would call minimum educational requirements. Then to your right is associate's degree. In many cases, an associate's degree is more than sufficient for a lot of the positions. High school diploma or GED, as you'll see, that actually is very useful and desirable, and as far as you need to go for many positions. And then trade school or experience. There's also, of course, a possibility for a combination of some of these. But that's the way we've broken up some of the information I'm going to provide you in these four levels of education. Are there any questions on this? We can always go back later, by the way. Oh, question? Okay. So here's a visualization of a module factory. Each of NuScale's modules are about the size of a steam generator for a large pressurized water reactor, about 75 feet or so high, and at the largest diameter, about 15-foot diameter. And here are some major categories of module manufacturing. They again are not all inclusive, but just to put into some perspective, the module itself, it's a structure. It requires steel, welding, and other manipulations. Then these are the other components of the module. So we have two estimates. These are estimates, I want to point out, and this is for the factory that produces the module, not the factories or the sources of material coming in, and not any of the other inputs to the construction itself. So for what we have determined as our first deployments, and that's a certain number of modules a year, which I'm not going to get into, we are estimating about 1,700 manufacturing jobs. And then what we foresee, what we're predicting as a long-term, larger and steady demand for module manufacturing, we're estimating approximately 5,000 manufacturing jobs. Now, can these be only in the United States? No, they can be in other countries as well. But that gives you an order of magnitude. And I use the term distributed just as it's footnoted here to further explain that the materials and components are sourced from many manufacturers. This is when they arrive at the factory to put together the module. Of course, the module factory, by the way, we would expect would also have NRC inspection requirements and testing as part of the overall process, so that we would take advantage of making many modules, which has been established in other industries. When you start making a lot of the same thing, you get efficiencies both in cost and schedule and quality. Okay, here is a slide that describes construction jobs. And again, these are estimates. This is for a 112 module plant. So for NuScale, we have three offerings for our SMR. We call our SMR, our trade name is now Voyager, V-O-Y-G-R. We have a Voyager 4, a Voyager 6, and a Voyager 12. And each of those modules is rated at 77 megawatt electric, 250 megawatt thermal. So for the largest, we are estimating about 1,171 construction jobs. And it's broken down by these different categories here. As you see, most of them are what I would call blue-collar workers, tradespeople, and a certain fraction are other categories. This was not just come up arbitrarily. We've actually had this reviewed several times by other companies that are on our team, including Fluor and Sargent and Lundy. Now the staffing of the plant. Here I provide numerical values for all three sizes and a list. I took out the numbers, but this is a list of the principal department or positions here, including security. And one of the reasons I took out the number is we're not going to provide the number of security people on a plant. The key takeaway I'd say here is I know most from other work I've done for sustain and information operating fleet, you get numbers in the order of 500 to 1,000 personnel, depending if it's a 1 reactor site or a 2 reactor site. So for our 12-unit Voyager, we're estimating approximately 270 personnel. And then you see it drops to 190 for 6 and 180 for 4. The difference isn't as great. This does take advantage of one very important accomplishment of NuScale amongst several, and that is our regulatory approval by the NRC for our 12-reactor plant, that if you follow the rules in the current Code of Federal Regulations for 1, 2, and 3 reactor large plants, we probably have 50 or 60 people in the control room. We were able to demonstrate, and the NRC agreed, that we would only need 6 reactor operators for our 12-reactor control room. And since then, we have revised that in a different top report, and they have now accepted 3. That's 3 at one time per shift. But still, that's a major accomplishment. And of course, the cost of electric powered a nuclear plant is very much dependent on, among other things, the operation cost of labor. So now I made a couple of very simple pie charts to break down the fraction by different functional areas that require different levels of education. For our corporate staff, it's 95% college degree and 5% high school diploma or GED. I don't think that is too surprising due to the nature of what is going on there. Module manufacturing is about 50-50, and here I just combined high school trade and nuclear experience, and then all different college degrees. So that's a 50-50 breakdown. For the construction workforce, shouldn't be a surprise again, but almost 80% of the workforce would be trade school. Not that they couldn't have other degrees, but trade school, and then about 20% college degree. And the power plant staff, this I think is one of the most interesting ones. It shows almost 2/3 of the staff would not require 4-year college or even a high school diploma, and they would be either an associate degree, trade school, or other nuclear experience, such as coming from the nuclear Navy. And that's got the smallest percentage of 4-year college degree requirements. I presented all this data in this table just to put it side by side. So obviously, depending on the number of plants you would expect and the schedule, you could manipulate these numbers of workforce to come up with a total expected growth in the workforce for how many Voyager SMRs would be built each year. I would expect the corporate staff to increase as well, because every one of these ordered plants would require a certain increase in the corporate staff to support engineering and licensing. If we suddenly had 4 or 5 sites that were all meeting a schedule for construction permit or combined operating license, that would require more individuals. So this is just a summary of the previous information, and that is portrayed both on plain slides and as pie charts. So NuScale, many, many years ago, before it became popular to say this now, recognized and even designed our SMR to be sized in such a way it could replace existing coal power plants that we expect will be retired over the next 10, 20 years. And we actually did a study to evaluate positions at a coal plant and what the equivalent position could be for a NuScale PWR, Voyager SMR. And so there are many areas where with some training or maybe even almost no training, the same people at a coal plant could work. And that provides another level of job security for coal plant operators, but it gives you an idea of how crossing technology, there are jobs that are transferable to coal plants. And this footnote here, I looked up all the coal plants I've been able to find, depending on their size, they employ anywhere between 50 and 150 workers for comparison to nuclear plants. So now I'd like to talk about what NuScale's approach is to nuclear workforce education, training, and development. And I did present these two slides at the Conte conference back in February, but I think they were important enough, and they give some suggestions of how the very difficult job that we have that Sustain is working on, and NEI has a project on, and Idaho National Lab, a lot of organizations and companies, not just in the nuclear industry, but other industries, are being presented with. And that is that we have to attract and retain employees from younger generations, and the requirements and what brings them in and what meets their career goals may not necessarily be the same thing as older generation people. So the first item I want to highlight is what we call our Energy Exploration, or E2 Center, and the deployment of that, and I'll cover that in more detail later. We have something at NuScale called the Ambassador Program, formal training and certification from our marketing communications team, and I am a graduate of that. And it allows the NuScale employees who are trained to talk about nuclear energy, NuScale technology, to public audiences, to professional organizations, other groups. I've done it several times, several universities, and I'll be doing it again next month, and also to professional societies. And so it helps to spread the word about NuScale, but it also helps to further inform the public about nuclear energy. And even to this day, there are so many times in different presentations when I hear some of the myths that have been around for half a century or more brought up, and it's difficult how one explains that. It is not a good idea to talk down to people. It's not a good idea to act like an all-knowing professional. That does not work. That did not work, TMI. So the method by which you communicate and listen as well is very important, so that you can help people form different opinions and also put them in touch with, dare I say, the truth, which not necessarily is common nowadays. Now I want to highlight the Sustain project. That's this third bullet. So I helped with the proposal, and I know we got a lot of letters of support from industry, and I am a participant, a gratis participant on this project to help it be successful. We're in the end of the first year of 3-year term of this project. Like a lot of companies, we do have an internship program. Approximately 20 college students come in at various times, and we do get a fair percentage of them staying on to become employees as well. That's not a new technique, but it's something that we do follow. Then, recognizing generational differences, we have a number of strong involvements in what I call generational outreach engagement venues. One of them is the North American Young Generation in Nuclear, NAYGN. There's a NuScale chapter. They're very much involved in public information, community outreach, networking, and professional development. And we also are very much involved in U.S. Women in Nuclear, or WIN, again, NuScale chapter with outreach, networking, and professional development. And we have a significant number of members of NuScale's staff in both of those. Finally, NuScale does get involved in a variety of STEM events. I know that Amber's on from University of Maryland, and she could attest to our getting involved with STEM fairs at Morgan State, science fairs, county science fair judging, other STEM events where we set up a table or a booth and introduce young people to what is nuclear, what is radiation, how does it help us, to try to make them more familiar with that. It's a job that's important, but there's so many students out there, and the level of education that is provided on this subject varies greatly, and certainly at the younger ages. And I firmly believe if we don't have their attention by middle school, then it's too late. And so, and I know that ANS and NEI involved in a lot of outreach in that as well. And then NuScale several years ago announced something called our Equal by 30 campaign. It's a commitment by the end of this decade that 50% of all our employees will be women or minorities, and 40% of all our management will be women or minorities. And we take that very seriously, and I think we're definitely well on our way to meeting or even exceeding that. Finally, well, it's pretty obvious, but in today's social media world, it's very important that you have as many links, many ways for people who refer to social media on the internet, website, Facebook, Twitter, LinkedIn, YouTube, Instagram, and keep it updated, not just have it, but keep it updated, active. We have a whole staff involved with that. It's very important for that. And finally, this is an interesting approach. So we don't always have people come join our company that come from a nuclear background at all. They may come from aerospace or other industries. So we have an extensive in-house training program. We have over 110 different learning core learning curricula and 1,200 training items, including 93 instructor-led. And many of these are designed specifically for people who come from different backgrounds, so they could learn nuclear or learn other aspects of how the company works. And that has been very helpful. I personally work in the group I'm in with a number of individuals that came to us from aerospace or other industries, and they found this opportunity of training to be to really help them, so they not just know acronyms but understand the nature of the business, the nature of what does it mean for quality assurance and safety and reliability and safety culture. All that is something very important. So now I'd like to spend a little time on the E2 Center. So NuScale has a 12 module full scale detailed simulator in our headquarters office in Corvallis, Oregon. It simulates all 12 reactors operating simultaneously and undergoing every possible upsafe condition that we can simulate. And it is one of the reasons of how we were able to convince the NRC that we didn't need a large number of operators. Basically, we would run events where the NRC inspectors would come, and there were things going on in all 12 reactors at the same time. Not normal operation, off normal things, refueling, pipe breaks, all failures. And what we would say to the NRC at that point, when they saw that all initiated, they'd say, "What do the operators have to do?" And our answer is, "We are now going to lunch." There's nothing the operators need to do for a long, long time, if ever. So we took that control room and we made a simpler, not as vigorous, but a simpler simulator lab that also shows how the NuScale SMR control room works and how the systems responds thermohydraulically. And the idea of this we call E2 Center was to provide an advanced understanding of technology in a control room setting for students, for researchers, for operators, and members of the public. So they could see something STEM related, and it's all digital screens, it's all state of the art, there's nothing analog in there. And so we to date have successfully deployed these at 5 universities: Oregon State, University of Idaho, Texas A&M, Idaho State, and the University of Bucharest in Romania. Romania is the first country in Europe that wants to lead in the deployment of the NuScale SMR. And recently we got news that the Department of Energy has agreed to support 3 more deployments in the upcoming months or through next year at Ohio State, University of Nevada, Las Vegas, and Rensselaer Polytechnic Institute. So what do these things look like? Here are some photos showing what some of them look like. I will tell you that except for maybe the number of screens, because Here you have a 4-module setup. There's one set of screens for each module, a center one, and this would be for the senior reactor operator. But except for that, they are almost exactly identical to what we have in our Corvallis office. So the picture is fine, but I think what would be better is if I show you a short video from Idaho State University of how the simulator helps their students and in employment and in training. So I'm going to stop share this screen for a second. And I'm going to share another screen. And there'll be a 3-minute video.
This is the future of how electricity will be generated. We'll supply energy across the U.S. and across the world. It is literally the future of our energy.
The Nuclear Operations Technology program is a 2-year Associates of Applied Science degree. 96% of our graduates have employment in the nuclear industry with an average starting salary between $70,000 and $100,000. We have the NuScale E2 Center, the largest one except for what they have at their headquarters in Oregon. We emphasize both control room operations, how to operate a reactor, how to enter and exit a control room, how to speak and log your work in one, and we also look at making sure students understand the appropriate electrical and mechanical systems and maintenance to help those reactors run even if they don't work in a control room. The NuScale simulator helps us accomplish that by giving students a place to practice those skills while also increasing their understanding of how a reactor operates and works.
This could be a hotbed for operators for NuScale reactors. And the thing about it is they're going to get experience regardless on new reactors. We also will partner to look to see how we can reskill people from coal-fired plants that are shut down into nuclear operators. And that's a huge thing. One of my goals actually is to find a way to reskill the working poor. These jobs right now today start at $85,000 a year, fresh out of our school.
The ESTech program has given me the opportunity to do many things that I never thought I would be able to do, like be out at the INL for a full summer and to get that real life experience of something that I want to do with my life.
Learning on the NuScale simulator is very unique and awesome. It gives us that opportunity to have a lot of different experiences because we experience the simulator, we experience glove box operation, and we experience the AGN 201 reactor on campus as well. And so having a variety of the experiences in this program, I think is really important for us students especially. I do feel like I would be ready moving into a facility.
The instructors in this program have gone above and beyond to provide us with industry knowledge and meetings with industry professionals. Now that I've seen the innovation and new technologies that this has demonstrated, that I believe that I would love to work at either NuScale or a similar reactor.
Okay, so I think that's all I have to present, but I would welcome any questions, and we can go back to the slides. Or if there's no questions, that's fine too.
Yeah, if there are any questions.
I see
Jonathan, you have a
Jonathan has
question?
raised his hand. Yes, sir.
I have 2 questions. The first one is the students that take part in the E2 program that you just shown in the video, are they all high school graduates, or do you, do you accept high school graduates? Because from the description, you do retool people from the coal industry. Apart from those, do you get fresh high school graduates into that program? Can they handle it if they just come from high school?
I believe the answer is yes. So,
Okay.
I mean, it depends what kind of high school graduate, of course.
Well, of course, yeah. I mean, all
Some-
things being equal,
yeah.
yes, yeah.
But here's 2-year students making $75,000 to $100,000.
Yeah, that blows my mind, you know. But I mean, That's incredible sale pitch there. Then this takes me to the very next question where I was writing it down. I think you mentioned it, but I want to get some clarification. Do you have materials that we can use or that can be readily used, or we can adapt it to reach students or schools and community at large, like pamphlets, flyers, posters, or activity workbooks or sheets, like the other federal agencies do? NASA is adept at that, and so does NOAA, so that we can introduce them to what is nuclear, what's nuclear energy, what's nuclear science, and then before they can, first of all, you got to, like you said, get their interest before they can even listen to the technical part and learn some things that will qualify them to go into a program like E2.
So what I do is I've gotten boxes of brochures and booklets from the American Nuclear Society, also from NEI. And when I go to these events, well, you could just go to a school. We give them out and we discuss it. We also have hands-on demonstration of a Geiger count and all. So I would say the best sources of this would be the American Nuclear Society, Nuclear Energy Institute, and then there is a Department of Energy possible source as well. But where I've gotten most of them has been the American Nuclear Society. Those three, and I would be glad to come to schools and do what I've done in the past at Morgan State and others. And you could do a light, it could be a light touch. We can go into more detail. It really depends on the student, the age of the student, and I'd like to tailor it to their attention span and what would get them interested and excited. So, I'd bring a little pellet this size out of plastic. I say, this pellet is as much energy as 150 gallons of oil, or this pellet could power your, we do some simple things, then a little bit more. Here's a smoke detector. There's radiation in here, but it's protecting your life. And let's talk about it. So, and you could start there and move your way up. But those are three sources: ANS, NEI, and DOE, I think.
Hey, Steve, there's a comment and a question. Jim Bychek just stated that other organizations might be IIIE and ASME, in addition to WIN and the Young Nuclear Group.
Yeah, I think ASME would, but IEEE, I'm making a presentation to them later next month, and I've done it before. They don't seem to have as strong a nuclear component, but ASME definitely has a whole nuclear, there's a whole nuclear part to ASME. So, and it doesn't hurt to check, and you could even look at AI Chemi and the others, but yeah, definitely ASME. And I see Max French sent a chat. I cannot answer, but if you could send me an email, Max, I don't know if you have my email address. It's SMIRSKY at NuScalePower.com. I will forward it to the right people. So I'm not in charge of communications, but it sounds like a great idea.
Yeah. Steve, do you have a TikTok?
No, I don't. I'm on LinkedIn. Does that count? I have a daughter who says I must only communicate to her by texting. She will not accept phones or emails. Those are antiquated, old, ancient ways of communication. So I have my own vocabulary I use now. When I text her, she has to figure out the vocabulary. It's single letters and numbers and dots and all.
Oh. All right.
Any other questions?
Yeah. Any other questions? Yeah. Okay. If not, Steve, thank you very much for your presentation. I of course have some questions, but I can take those offline and we can talk about them in our group. The one thing that would be interesting is to see what NuScale is focusing on in terms of their education. And I also noticed the overlap between conversion of coal units to nuclear. Let's say TerraPower is certainly doing that in Wyoming. And from what you were talking about with NuScale, though, it all sounds like the sites and the personnel.
Yes, the Romanian site is a coal plant, by the way. So, and they've ready It's amazing, you know, you see everything online. They had the picture before and after. It's all been leveled completely and prepared for construction. And I understand there are a lot of other countries in Europe as well, of course, in the US, where there are coal plants that are soon to be shut down. The only problem there is, and TerraPower, I think, will recognize this and others. So when they contact us, they want to know how quickly we can build it. They're used to building coal plants or natural gas in 2 or 3. Can you build it in 2 or 3 years? What do you mean you have to have it licensed? What is this licensing stuff? I don't understand. We just want it right like that.
All right. Okay. Thanks, Steve.